All right, we have made it to the last part of 22.2. The last part is all about making and analyzing a box plot. So, first of all, what is a box plot? A box plot is also known as a box and whisker plot. And you guys have all seen these before. You have worked with them in some capacity, so I expect you to be kind of familiar with this. Now, a box plot is based on 5 key numbers. Okay, the minimum data value, the first quartile, the median, the third quartile, and the maximum data value. Now, if that sounds familiar, it should, right? When we looked at using the calculator, how to use our graphing calculators, we learned to find statistics. And if you remember the bottom values, that minimum x, the Q1, the median, the Q3, and the max x, and that's the way they're listed once you find your statistics. This is the data we need to create our box and whisker plot, okay? So when we set up our box and whisker plot, let's go through this. This here would be our minimum value, right? Smallest value. This is known as one of our whiskers. Then we have our lower quartile, which is Q1. We have the median, which is also known as Q2, rarely referred to as Q2. Then we have our upper quartile, also known as Q3. And finally, we have our maximum value at the end, okay, along with our second whisker. Now, what do we know about box plots? Well, our box is in the middle. It's made up from quartile 1 to quartile 3, which is also the IQR, if you guys remember this. The difference between quartile 3 and quartile 1 is what gives us our IQR. But what is also not known about box and whiskers plots is that they are always, always, always evenly split between our data. That means that this section here is 25% of our data. This section here is 25% of our data. Our whisker is also 25% of our data. Okay, so it is split up into 4. It doesn't matter if your box is on the left, on the right, your data is always distributed into quartiles in a box and whisker plot. All right, so looking at A, it says the list gives the ages of a random sample of 16 people who visited a doctor's office one day. What I want you guys to do is, again, practice with our calculator. Okay, you have the data here. You're going to take this data, input it in your calculator, and find those statistical values. So remember, in order to graph, we need those 5 values. Identify the minimum, the quartile 1, the median, quartile 3, and maximum value. Okay, so hit the pause button, enter this into your calculator, and come back and check it in a minute. All right, so these are the values you should have found in your calculator. Your minimum value is 35, quartile 1 is 67, median is 76.5, and your quartile 3 is 80, and your maximum is 82. Okay, now I know some of you are thinking, well, that's easy. I'm just going to make a line and draw my box plot. Remember that your data values have to be in equal intervals. That means I can't just draw a number line and say here's 35, here's 67, right? If we're going to draw a number line, you have to have evenly spaced intervals. So we're going to draw a number line. Your box plots always have number lines. And I'm going to start at 35. And because we're going up to 82, I'm going to go by 5s, which just makes more sense and it'll save us some space here. So I'm going to go by 5s. And I'm trying to space them out evenly. I know it's not perfect. All right, so I'm up to 80. Remember, our largest number is 82. That means I need to go up to 85. So here's my number line. Now I'm going to go ahead and plot those 5 numbers. So I have a point at 35. I have a point at 67, which means I'm going to have to estimate here. Then we have a point at 76.5, a point at 80, and a point at 82. Okay, once you have those 5 points, draw a line straight through them. Oops, makes it hard to see my points here. Okay, and then we're going to draw our box. Now remember, box and whisker plot, you go to your center 2 points. Okay, you go to your quartile 1, which in this case is 67, and quartile 3, which is 80, and draw your box using those 2 points. Straight line down the center, our median, and there's our box and whisker plot. Okay, now when it comes to describing this graph, remember, this is still 25% of our data. It doesn't matter how large it looks, right? It's still 25% of our data. Just like this little portion here is still 25% of our data. Hard to believe, I know, but box and whisker plots have outliers, which if you guys haven't noticed, our outlier is 35. That's why our tail is so extended. Okay. Now for part B, how does the box plot show that the data is skewed left? Well, how do we know it's skewed left? Do you guys remember when we talked about skewed distributions? A skewed distribution has one tail that is much longer than the other. And if you look at the diagram here for skewed left distribution, it matches our box and whisker plot. So how do we know it's skewed left? Because our left whisker is much longer than the right whisker. Simple as that. Okay. And part C, suppose one of the ages is chosen at random. Based on the box plot and not the original set of data, what can you say about the approximate probability that the age falls between the first quartile, which is here, and the third quartile, which is here? So, based on what we know of box and whisker plots, how much data would fall into this specific area? Again, keep in mind what I just told you guys. We have even distribution when it comes to box and whisker plots. That means that 25% falls here, 25% falls here, 25% falls here, and 25% falls here, meaning that inside of our box we have a total of 50% of our data. That didn't even require any work on our part. And part D, suppose one of the ages is chosen at random based on the box plot and not the original set of data. What can you say about the approximate probability that the age falls below the third quartile? So now we're looking at this data here. How much data falls below the third quartile? Well, if you look up at our diagram, below the third quartile, how much data is here? 75%.